Hello and welcome to today's class. For this class, we'll look at the concept of properties of wave. In our last class, in our previous classes, I've done a video on waves, right? And we said a wave is simply a disturbance that travels through a medium, transferring energy from one point to another without causing any change in displacement. That's like wave definition. Last class also, we look at the classification of wave based on medium of propagation and based on what the direction of travel. Under the first one, we have mechanical wave and electromagnetic wave. The second one, there we have the transverse wave and what the longitudinal wave. So we'll look at all this stuff in our last class. We also look at the equation of a wave, where I have that y is equal to a sine into 2 pi x over lambda minus 2 pi ft. This is called the equation of a wave. We have dealt with this in our last class and we have solved several examples based on this piece. Now let's now look at yet another concept called the the properties of wave. We have about 5 properties of wave. The first one, there we have the reflection. Number 2, refraction. Number 3, interference. Number 4, diffraction. Number 5, we have the plane polarization. These are the 5 properties of wave that we have, please. Let's look at these 5 properties of wave one after the other. For this class, I'll focus more on the first one called deflection. So I'll focus more on this. So let's look at this, please. Let's look at the first concept called reflection, please. Please, let's look at the concept of reflection. All right. Reflection of light wave. Light wave. Let's look at the concept of reflection of light wave, please. Definition, please. Reflection is the sudden change in the direction of propagation of a wave as it strikes the boundary or interface between two media. That's your definition for refraction. So if you have to define refraction is the sudden change in the direction of propagation of a wave as it strikes the boundary or interface between two media. All right, let's explain this concept of reflection. So let's say first, I'll draw out my boundary. This line here is said to be the boundary, right? All right. I'll have this line here is called the normal. I have this and I have this way. All right. So this place here is I, here is R, here is going inward, that's coming outward, please. So this man here, I just call this man the boundary, right? All right. This diagram here represents the reflection at a plane surface. All right, please look up, please. Let's explain this, please. Now listen up, please. When it comes to reflection of light wave, get the concept, please. In this diagram, there are some matrices you need to be familiar with this as we proceed, please. Now look up, please. Look up. First, the first matrices you need to note is this line here. This line here is called a boundary, please. Note that this line here is called a boundary, please. Now, why this shading here? I'm shading this to differentiate between the two media. I have upper media and lower media here. This lower media here is said to be the boundary. So if I just come around here and draw this way, you can't really tell which one is the boundary. Now to show the boundary, I have to put what there, a rough stuff there to indicate the boundary concept. So that's the first matrix to note. Number two things to note under this diagram is your direction, please. This direction, please. Now observe where the arrow is going inward. The angle formed there was what there. All right, hold on, please. All right, hold on, please. Note something, please. Note something, please. Where I is called the angle of incidence ray. Incidence. While R is called angle of angle of reflection per se. Right, reflection. Angle of reflection, please. Incidence, angle of reflection, please. Note that I is called angle of incidence, R is called angle of reflection. So here's the concept, please. I'm saying that, look up, please. Another thing to note, we said the point to note under the diagram is called your boundary. Next thing to note is called this line that goes in and comes out here. Now, note when your arrow is going inward and outward. If your arrow is going inward, this will signify what the incidence ray. Why when you go outward, this line will signify what the reflection ray, right? So I'm saying that when it comes to this diagram, there are key to note. Number one, your boundary. Number two, the direction to which your arrow indicates. If my arrow, observe this, if my arrow here is showing inward and here is showing outward, in this case, please, where will be my angle of incidence, angle of reflection? It's easy as this one is coming in because of the angle of what? Incidence. This one because of the angle of what? Reflection. Why? Because the arrow here will tell me what I expect to see. Hold on, please. Look up, please. Now from there, please. Now listen. Let's graph, please. First to note your boundary. Next up, note your what? Your direction. Next task, please, note this straight line here. This straight line here is called normal. This one is called normal. All right. What is normal? For those that are doing engine drawing, you should know what is normal, right? A normal is simply a line that meets another line at what? At 90 degrees. So this line here is meeting this line at what? At angle what? 90 degrees. Observe, please. At what? 90 degrees, please. So I've explained virtually all what you need to note here, right? And here's the concept, please. In exam, they can ask you to define angle of incidence, define angle of reflection. How do you define it, please? If they ask you, please, what's I? What's R? Right? What's I? What's R? All right. So look up, please. All right, let's proceed, please, from here, please. All right, let's start, please. I've tried to explain this diagram as much as I can. So please, let's continue from this point, please. So at this junction, note something, please. Note a key concept, please. Note, please. Note that, please. Experiment shown that from experiment, put on, please. From experiment, it has been shown that the angle of incidence is equal to the angle of reflection. From experiment, it has been shown that the angle of incidence is equal to the angle of what there of reflection, please. That is I equal to R. So look up, please. From experiment, it has been shown that I equal to R. What does it mean, please? Now look up, please. If the angle of I is 35, it means that what? The angle of what? Reflection is what? Is also what there? 35. Why? I equal to R concept, please. So these are like what you need to note when it comes to the concept of reflection of a wave. All right. Let's proceed to other concept, please. So before I proceed to the laws under, what's it called? The laws under reflection, let me explain something technical, please. Let me explain something, please. All right, look up, please. Look up. Look at this man here. Look at this diagram, please. Look at this diagram, please. Let me draw it per se for clarity. So look at this diagram, please. Look at this diagram. I have my, I want to reproduce the diagram, please. This is my normal. All right. Now, please, if I do this one for you, which one here is the reflected ray? Which one here is the incident ray? Here's the concept, please. I don't know which one is incident and which one is what the reflected ray here. Why? Because I don't have arrow here indicating. So the arrow tells you exactly where you are going. My arrow, I don't have arrow here, please. So in case I don't have arrow here, I don't know incident. I don't know what the reflection. Now, if I put an arrow here, look up, please. If I put an arrow here this way and this way, now you can tell me where is incident, where is what the reflection. The inward line here is called what is called the angle of what incident. Here because what the angle of what reflection is going outward, please. That's first thing to note, please. Now I asked you earlier that if you are asked to define I R, what do you define? How do you define I and R? Please listen. I is called what the angle of what incident. Now, what is angle of incident by definition? Angle of incident can be defined as the point, or perhaps as the angle, can be defined as the angle formed when the incident ray and the normal formed, right? The angle formed when the incident ray and normal meet is called what the angle of what incident. So angle of incident I can be defined as the point or the angle formed when the incident ray and the normal meet, right? That's like how you define the angle of incident. You can also define angle of refraction by logical extension. So angle of reflection can be defined as the angle formed when the reflection ray and the normal meet. So the angle formed when reflected ray, this one here, and the normal meet is called what is called R, and R is called angle of what reflection. So this is how you define I and R in case please. So I'm done with defining I and R. So look up, please. Look up. We establish now that I equal to R. What does it mean? Now, if let's say I have that I is equal to 35 degrees, what does it mean? It means that what R is what 35 degrees. It's easy. It's easy because said I equal to what equal to R. Now, here's the concept, please. In exam, they might confuse you, please. Now, here's what to note, please. We said this angle here formed is what a right angle. We said a normal is a line that meets on that line at what 90 degrees. So this normal here is from 90 degrees to this part and 90 degrees to this part, please. Now here's the concept. In exam, they might not give you angle of incident or reflection. They will not give you another angle. Now in this diagram here, look up. Let me describe this down. If I draw this one this way, this way, this way, this way, there are 4 possible angles here. All right, let's say I have angle A, angle B, angle C, angle D. Please, angle A, B, C, D, which one is incident ray? Which one is reflected ray here? I don't know. I can't tell. Why? I don't have arrow indicating. Let's say I have arrow here, this way and this way. It's clear that B here is angle of what incident. C here is called what the angle of what reflection. Please, here's the concept, please. If I look up, we said B is what angle of incident. If I'm given A, is it possible to find B? Of course, yes. Why? Because this normal and this horizontal surface here are forming what 90 degrees. So if I'm given, hold on please, let's say I'm given A as 60 degrees. Can I get B? Yes. How? If here's the concept, please. This one here is from 90 degree. It means that if I had A plus B together, it should be what 90 degrees. If A is 60 degrees plus B equal to 90, to get B, I'll subtract 90 from 60. So B here is what 90 minus what 60, and that will give what there. So my B will becomes what there 30 degrees. All right, 30 degrees. So it means that my incident ray now is what 30 degrees, please. So just note that the angle formed there is what? 90. Here too is 90. So it's easy to find angle of incidence if we are given angle of what? The angle between the incident ray and the horizontal surface. So this A that I was given was the angle between the incident ray and the what? And the horizontal surface, please. So here's how the technicality of this thing works, please. So let's proceed from here, please. Let's proceed from here. Let's look at laws of let's look at laws of reflection. Let's look at some laws of reflection, please. Laws of reflection. Laws of reflection. All right, please. When it comes to law of reflection, there are three distinct laws of reflection. There are two laws of reflection. Let's look at this law one after the other, please. Law one, please. Law one says, please. The law one says, please. Law one says that the angle of incidence is equal to the angle of reflection. Please. Law one says the angle of incidence is equal to the angle of what? Of reflection. That's the law one of reflection. The law two, let's look at law two, please. All right, let's look at the second law governing the concept of reflection. So I said the first law says that the angle of incidence is equal to angle of what? Reflection. That's law one. Law two says that, put on please, law two says that the angle of incidence, comma, angle of reflection, comma, and normal all lies on the same plane. That's how you set the law 2. Observe that angle of incidence, angle of reflection, and normal all lies on what there? On the same plane. That's how you state the second law of reflection. So let's, at this junction here, let's take few problems, have few past questions, and solve and see how you can possibly evaluate problems in the concept of reflection. So, step one, please. Step one, please. Light is incident on a glass prism at an angle of 35 degrees. What is the angle of reflection? All right. It's easy, please. Number one says, it says that light is incident on a glass prism at an angle of what there? 35 degree. Sorry, 53 degrees, please. That 53 degrees, is it I or R? Please check. Is 53 degrees there, is it I or R? It's as easy as I'm going to what? Angle of incidence. Angle of incidence there is what? Is of course I, and is what? 53 degrees, please. Now, if I is 53 degrees, I'm asked to find R. And from law 1, we said I equal to what? R. It means that if I is what? 53, definitely R is what there? 53. So therefore, my angle of reflection is what? 53 degrees. That's how you solve number one question, please. That's as easy as that, please. Just ensure that your law 1 goes in place of this, please. If I is 53, definitely R is what there? 53. From what? From the first law of reflection. Example 2, please. It says that light is incidence on a surface at 40 degrees. Listen, oh, light is incidence on a surface at what there? 40 degrees. What is the angle between the incident ray and the reflected ray? Please, let's do number 2, please. Example 2. Example 2 says that, listen, it says light is incident on a surface at what there? 40 degrees. So I'm giving what there? The angle of what? Incident as what? 40 degrees. Now listen, what is the angle of what? What is the angle between the incident ray and what? The reflected ray. I'm not asked to find R here. I'm asked to find the angle between the I and R. Now listen up. The diagram for this is this, please. Let's say I have my boundary and I have the incident ray here. I have my reflection ray and I have my normal here. I'm given that I here is what? 40 degrees. And I'm asked to find, and we know that here is R normally. I'm asked to find the angle between what? The incident ray and what? The reflected ray. So I'm asked to find the total angle here. Now listen, if I is 40 degree, what we know from now is that R is what? Also what? The 40 degree. Now to find the total angle between I and R, I have to sum up what? 40 plus what? The 40. So here's the concept now. I plus R becomes what? The 40 plus 40 will give what? The 80 degrees. So the total angle between I and R is what? There is 80 degrees, please. So ensure sometimes you need to draw this diagram to identify what you're asked to do in some cases, please. So this is how you solve this problem. Let's take one more, please. Let's take one more. Let's take one more. All right, let's take one more. Example 3, please. Light ray falls on a surface and then reflects. If the angle between the light ray and the surface is 38 degrees, number 1, what is the angle of reflection? Number 2, what is the angle between the incident ray and the reflected ray? All right, let's do number 3, please. Example 3. First things first, I will have to draw out my concept of reflection. Right, I have this. This man here is I, here is R. Now listen to the question, please. It says that light ray falls on a surface, no problem, and then reflects. Okay, if the angle between the light ray and the surface, angle between this is sorry, this is my light ray, reflected ray, please, reflection ray. This man here is the line, is the reflection incident ray, please. And I'm told that if the angle between the light ray, or you call it incident ray, and the surface, observe please, and what there, and the surface, so it means that the angle given there is not angle of incident, is not angle of what? Reflection. Rather, the angle between what? The surface and what? Light ray. So the angle here is what? 38 degrees, please. The angle given there, 38 degrees, please. All right, next task, I'm asked to find what is the angle of reflection and the angle between incident ray and reflected ray, please. Now look up, please. First, I have to get I in this case. Let's get I first. To get I is easy. We established that the angle between normal and this surface is what? 90 degrees. So it's as easy as saying I plus 38 equal to what? 90 degrees. From it, let's get I. I is equal to 90 minus what? 38. If I do my normal math, I is what? 52 degrees here. So I'm not asked to find the angle of incident. Question 1 says, what is angle of what? Reflection. Since I've gotten angle of incident as 58, therefore my angle of reflection becomes what there? 52 degrees. Since I've gotten my angle of incident at 52 degrees, definitely angle of reflection R is also what there? 52 degrees. This is how you work on this. Question B says, what is the angle between the incident ray and reflected ray, please? So it's asking, what's the angle between incident ray and what? Reflected ray. Reflected ray is as easy as what? Adding what? 52 with what there? 52. All right, let me do number. Let's do B. So question B says, find the angle between incident ray and reflected ray. It's as easy as adding your two angles. So that becomes I plus R Of course, I is 52, R is 52. This will give about 104 degrees. So the angle between incident ray and reflected ray is 104, as you can see. This is how you solve this particular question here. So let's look at yet the second properties of wave in our next class, known as refraction. So we are done with the concept of reflection of light. So let's look at the concept of refraction in our next class.